Hi everyone, we are Senior Design Group 27 and our sponsor is Veeder-Root, who are well known for their field management technologies. So the problem Veeder-Root proposed to us was that they have different tank gauges installed at different gas tank sites around Connecticut, and their tank gauges measure different metrics like the gas tank fuel height, water height, and temperature, which are important metrics in keeping track of the tank's health. However, the data retrieval for these gauges is actually physical, which means that the engineers have to physically go to the site if they want to see the data or make any changes to the system. And on top of that, the data returned is actually in a raw format, which makes it hard for the engineers to use. So as a solution, they asked us to create a cloud-based field management system, which allows engineers to access any tank data remotely, and the raw data is converted into a readable format. So this data is actually uploaded into a cloud environment where the engineers can use a web application that we developed to see any of the data they want at any tank site, at any tank, at any time interval. And then the data we receive is a formatted, downloaded CSV file.
Our solution involved creating a system that has three main components: the Beagle board, which interacts with the tank gauges, the Amazon Web Services database, which allows for cloud-based data storage, and the web application, which provides a graphical user interface and allows users to enter requests remotely. From the web application, a user is able to enter a request to either query for data or to send a polar reconfiguration request. If the user queried for data, our AWS database will be able to return them the requested data in a readable format. If a polar reconfiguration request was entered, it will be passed through our system to the Beagle board, which will use serial commands to update the polar based on the user's request. This solves our problem by providing an interface that allows the user to display and interact with the data measured by the tank gauges remotely, so the engineers no longer need to physically go to the sites just to retrieve data or to reconfigure the polars. The interface is also intuitive enough for non-technical users to be able to use the application, and the data is returned in a format that is easily understandable.
So let us look at a run-through of our product. Suppose you are looking at the Veeder-Root fuel management system and you are a Veeder-Root engineer and would like to see one of the data from the beta site. Specifically, Jimmy Yukon food truck. The tank in questioning is 87, 89 in diesel. The data that we would like to look for is fuel height, water height, temperature from the date of March 28th to April 2nd. Data is obviously requested, submitted, and now you can obviously view the data you requested by simply clicking View Data Request. The data is automatically generated and returned to user on the web page, in which you can view. And you can see the time frame is from March 28th to April 2nd. Another cool functionality that we have within the web is that you could reconfigure the polar devices on the fly through the web framework. Simply click Reconfigure Device. In this, we're going to modify Jimmy's Yukon food truck. We're going to change 87 octane. We're going to change the in-tank report to in-tank delivery. And we're going to change to every 4 hours. And now the reconfigure request has already been submitted and successfully been implemented. So we can see that in real time that the files have actually been changed by looking at the configuration files, specifically for the polar devices. And now you can see that 737 represents, the Yukon beta site. That changes from 202 and every 4 hours. And that is a demonstration of data retrieval and polar reconfiguration requests.
Now that you've seen the web application, we'd like to demonstrate the polar device and the BeagleBone. The BeagleBone is a single board computer that runs Debian Linux, and it pushes up our data to the cloud environment, which is hosted by Amazon Web Services. We can use the Cloud9 IDE to show the Linux terminal that runs our code. And here we can demonstrate pushing up an in-tank inventory and in-tank delivery report. As you can see, we have a folder for today and a new CSV file for beta site 2. Finally, we demonstrate extracting information from the TLS polar device. We should now see our data populated in the folder for April, and if we refresh the page, for today's date. For the in-tank delivery report, we see data points such as volume, fuel height, and temperature that users can select and query from the front end of the application. The in-tank delivery report shows several data points measured at the start of the delivery and then again at the end of the delivery.